Welcome to the AERO 210 tutorial and preparation for the airfoil lab. Please review the following slides to help familiarize yourself with the wind tunnel and lab setup prior to your arrival. Here's an overview of the wind tunnel located in Fairchild Hall, room 5J14. Note the test section in the center. It is a 12-inch by 12-inch test section that houses the NACA 2415 airfoil that we'll use for our lab. The intake to the wind tunnel is equipped with a honeycomb flow straightener. This prevents any swirling effects as the flow enters the test section. The airflow also experiences pressure losses while passing through the honeycomb flow straightener. The NACA 2415 airfoil spans wall to wall in the test section. This eliminates any wingtip effects and mimics an infinite airfoil. The tufts of string help to visualize the airflow as it passes over. The angle of attack is set by this lever and knob. Use it to control set the angle of attack in the test section of the airfoil. However, please do not let go of this knob until you've tightened down the two knurled nuts pictured on the next slide. If the airfoil is allowed to spin freely in the test section, it could potentially break off, travel down the wind tunnel, and damage the fan and motor. The test section also incorporates a pitot probe that measures both total and static pressure. It is displayed, however, as inches of oil on the manometer. Static ports on the upper and lower surface of the airfoil enable us to collect static pressure data. That static pressure is then transmitted via tubes to the manometer bank. Also pictured here are the knurled nuts used to tighten the airfoil adjustment knob in place. The manometer is filled with oil and is connected to both the upper and lower surfaces, as well as the pitot probe. When the airfoil is under load, or in other words, the wind tunnel is operating, static pressure will be displayed in inches of oil on the manometer. Here's an example of the oil columns as they are displaced once the wind tunnel has been turned on. You will read the heights of these oil columns at the bottom of the meniscus in inches of oil and convert those to pressures. We also have a barometer and digital thermometer help measure the atmospheric conditions of the room. Take especially note of the units used in the barometer. They are in inches of water, and the thermometers in degrees Fahrenheit. Both of these will have to be converted for use in our equations. Before you come to the lab, please ensure you review the rest of this slide deck. Review the cautions, warnings, and notes. As a team, you'll monitor both the manometer oil bank, the behavior of the tufts of string, and the angle of attack you'll set on the wind tunnel airfoil. Think about what will happen to those columns of oil as we increase angle of attack, or how the tufts of string may behave as we increase angles of attack. Here are the cautions, warnings, and notes as they are displayed in the room. Please take a moment to review these. Here's a basic procedure that you'll follow. You'll rotate the airfoil via the knob and handle to your assigned angle of attack. Observe the behavior of the tufts of string. Finally, you'll read the manometer oil heights in inches and record that data for later use. Again, make sure you do not let go of the airfoil knob until both knurled nuts are tightened down safely and securely. After the lab, please ensure that you review your data and enter it into the spreadsheets as instructed. Complete your airfoil lab assignment. And remember, you may work in your teams, but everyone will turn in an individual lab report. Good luck.